So there are many methods, there are many ways of solving linear quadratic equations. So number one is solving by factorization method. Let us look at the algorithm first. Just read these things. Step 1, what is step 1? Factorize the constant term. Step 1 says factorize the constant term of the given quadratic equation. Step 2 says express the coefficient of the middle term as the sum or differences of the factors obtained in step 1. Clearly, the product of these two factors will be equal to the product of the coefficient of x square and constant term. Step 3 says split the middle term in two parts in step 2. And step 4 says factorize the quadratic equation obtained in step 2 by grouping method. So let us now take some examples to solve this. So here is a first example. Question number 1, it says 8x square minus 22x minus 21 is equal to 0. So all you need to do is you just need to split up this term. Okay, this term we will first multiply. If there is a coefficient like this, we will multiply this with this. It comes to be 168. So let us solve it. It's equal to 8x square minus 28x plus 6x minus 21 is equal to 0. Right. So what we did, we multiplied 8 with 21. It gave us 168. So now 168, we have to write this in such a way. We have to write this 168 in such a way that we have to break this middle term factor. We have done middle term factor, right? So we have to just do this middle term factor, so that when we evaluate this thing, we will get 22x. But when we multiply 28 with 6, we will get 168. That is how these sums are done. Now we will just evaluate. This is equal to, so we can take 4x over here common. 4x, 2x minus 7 plus 2x minus 7 equal to 0. This is equal to 4x plus 3 and 2x minus 7 is equal to 0. So x will be minus 3 by 4 and 7 by 2. These are the two values. Now we will do question number 2 now. Here we will multiply 9 with 2. It gives us 18. Right, multiply 9 with 2, it gives us 18. So we need to break up this 3 in such a way that the difference of two numbers would give us 3, and the multiplication of those two numbers will give us 18. So what is it? It will be 6 and 3, right? So we will write it as 9x square minus 6x plus 3x minus 2 equal to 0. Now we will simply take 3x over here. It will be common. It will be 3x minus 2 plus 1. We can just write 1 over here. 3x minus 2. This is equal to 0. Now we will take, suppose, 3x minus 2 and 3x plus 1 is equal to 0. Okay. Now x will be equal to 2 by 3, right, and x will be equal to minus 1 by 3. Okay, simple. Now let us do number 3. In question number 3, there are roots. Okay, so the method is simple. The method is the same thing. We just need to maintain the algorithm. We have to maintain the thumb rule no matter what the question is. So what we will do, here it is root 3. We will multiply root 3 with 7 root 3. This is the constant term, right? This is in the entire equation. This thing is the constant term, like the C term in the general form. So we will multiply root 3 with this. It gives us 21, right? It gives us 21. So we will split 10 in such a way. We will write 10 as the sum of two numbers, and when we multiply those two numbers, we will get 21. How we will do that? We will write 3x square plus 7x plus 3x plus 7 root 3 is equal to 0. This is equal to, so here what we will take common? We will take root 3x common. We can do that. So this will be x plus 7 root 3. Here we will take 7 common. we will take this will be, yeah, you here will take 7 common, so it will be x plus root 3 equal to 0. Here the 7 will not be there because we are taking common from this and this. We have taken root 3x common, and then we are taking common from this and this, okay, and it gives us this. So this will be x plus 3, we will take x plus 3 common, then it will be root 3x plus 7 is equal to 0. This will be x is equal to minus root 3 and minus 7 by root 3. Okay, these are the two values. Now we will move on to the next sum. These all are the factorization. This is a little complex, but the rule will be same. It's not so complex. The rule will always be same. So that thing is constant. So here what we will do, here we will just do the LCM. Just take the LCM. This will be x minus 2, x minus 1, right, and this will be x minus 1 plus 2, x minus 2 is equal to 6 by x. Simple enough. Now we will just cross multiply. We will just solve this numerator. It will come to be 3x minus 5, and I'm directly doing the cross multiplication also. Here it will be x. This will be equal to 6 into x minus 2, and I'm writing here x minus 1. After that, if you solve this, you will get, it's coming 3x square minus 5x, yeah, and this will be 6x square minus 18x plus 12. Now you just need to reshuffle and simplify, take all the things in the left hand side, so it will be 3x square minus 13x plus 12 is equal to 0. Now this will be, we will multiply 3 with 12, it is 36. Now we have to split 13 in such a way, 13 will be expressed as sum or difference of two numbers in such a way that when we multiply those two numbers we will get 36. So how will we split it? It will be 9 and 4, so this will be 3x square minus 9x minus 4x plus 12 equal to 0. So this will be, we will take 3x over here common. One second. Yeah, we will take 3x over here common. It will be x minus 3x minus 4 x minus 3. This will be equal to 0. Now 3x minus 4 and x minus 3x, this will be, x will not be here, this is equal to 0. Now x is equal to 4 by 3 and x is equal to 3. Okay, now this sum is a little complex, but we'll the same thing, we'll apply the same algorithm, the same logic, that's it. So here what we will do, we will try to write the constant term first. We will try to break the constant term first. So what is the constant term over here? The constant term, let me write the constant term. The constant term is this. This is the constant term. So I'll write the constant term as 2a square. There's a little, this will be square. Okay, 2a square plus 4ab. We will write it like this, plus ab plus 2b square. We need to break the constant term. Okay, we need to break the constant term in such a way, we need to, this is the constant term, so we need to write this constant, this algebraic expression as the multiplication of two terms, so that we can take the entire thing common. This is a, okay, this is a, it's not 9, it's a. Now this is, now here we have we will do the middle term factor of this thing, this constant term. We can write it as 4a plus b. So from here we can take 2a common. If we will take 2a common, it will be a plus 2b, a plus 2b. From here we will take b common, it will be a plus 2b, right? So this is equal to 2a plus b and a plus 2b. So we have this as a constant term, and this constant term has been simplified to this. So we will rewrite this constant term in this equation. So after rewriting the constant term, it will look something like this: 9x square minus 9 a plus b x plus 2a plus b, a plus 2b. Whenever you have a complex equation, like there are many terms in like this equation, what you will do, if you see that in any part, let it be the constant term part, let it be this part, let it be the leading coefficient part, if you can see that you can break those up in the middle term factor, we'll just do that. This is done. Now what we will do, we need to break this thing up, because this is a middle term, right? So we will write it as 9x square minus 3 outside 2a plus b plus a plus 2b. Okay, close the bracket, write x over here. So what is our main aim? We have a plus b over here, and we have 2a plus b, a plus 2b, this constant term. So we need to write this middle term. We need to write this middle term in such a way that this thing can appear in the middle term, and then we will copy the rest, because we need to take common, right? So if you want to take common, the like terms on one side, and we need to do the common thing that we did over here. See, this is the common thing, right? We took this thing common. This was this x minus 3, x minus 3, x minus 3 common. When you take x minus 3 common from here, what we are left with is 3x minus 4, 3x minus 4. So that is exactly what we are trying to do over here. We are taking these terms over here, we are breaking this up as sum and difference, so that we can take things common. You will see what will happen over here. So this can be written as, how can this be written as? We will take the 3 inside, we can do that. 9x square minus 3 2ab, this will be x, there will be another minus 3a plus 2b x plus 2a plus b, a plus 2b is equal to 0. Now just let me just write this. Yeah, okay, let me just extend this line, or yeah, okay. Now what we will do, now we will just take common, because we have the expression. We can take common this, we can take common, and here these things we can take common, right? We can do that. So that's how we will take common from the first term. From the first term, as you can see, we can take 3x to be common. If 3x is common, then this is what? 3x, this will also be 3x minus 2a plus b, right? And from the second term, from the second expression, we can take a plus 2b common. That is the only common thing here and here. A plus 2b, a plus 2b. That is the only two repeating terms, right? So we can take a plus 2b common. So if you take a plus 2b common, it will be 3x minus 2a plus b. Simple. That is equal to 0. Now this is equal to 3x minus 2a plus b. This is common, right? 3x minus 2a plus b, 3x minus 2a plus b, multiplied by 3x minus a plus 2b. These are the two products that we are getting. These are two products, right? So now what we will do, so x will have basically three values. One is 3x minus 2ab, this thing, or 3x is equal to a plus 2b. So x is basically equal to 2a plus b by 3, or x is equal to a plus 2b by 3. Simple. So that is how we do these sums. When you see that the expression, the term, the question that you are given, the equation is a complex one, what we will do is that if you can just like factorize, if you can factorize the entire thing, if you can factorize this, then you will do the middle term factor of the constant term, and then we will express this like this, and then we will take inculcate these two expressions in the middle term. So this is how we solve by factor.